Okay, good afternoon, everyone. Welcome to technical session 7F. I'm Deepika Jain, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GIA Scholastic LLP, it is my great pleasure to welcome you all to the 9th International Conference on Smart Trends in Computing and Communication, SMARTCOM 2025, Pune, India. The 9th edition of the conference has been organized in a hybrid mode. The physical event was held yesterday in Pune, India, and the virtual event is being held through Zoom, that is on today and tomorrow, 30 and 31st January. I hope you will enjoy the knowledgeable sessions throughout the day. In this session, we have 10 presentations, and each presenter would be getting 8 minutes for their presentation and 2 minutes for their question and answers. On 7 minutes, I'll be raising a gentle reminder. I also request all the participants to be with us till the end of the session. And I also, if any of the participants have any query, they can reach out to me to the chat box. Before we start the session, just a minute. Can you please, yeah. Just a minute. I would like to introduce to our session chair, Sangeeta ma'am. I welcome you, ma'am. Dr. Sangeeta is an associate professor in the Department of Electronics and Telecommunication Engineering at Vishwakarma Institute of Technology, Pune. With a PhD ME in electronics, she brings 29 years of academic experience to her role. Specializing in wireless communication, Ma'am has been a valued member of the Institute since 2002, contributing extensively to teaching and research in her field. Thank you, ma'am. I welcome you.
Thank you. Thank you, Deepika.
Thank you. Okay, we can start with our first presentation. Just a moment. Syed Abid Hussain is here, who would be presenting a paper on 6G, a revolutionary transformation, network congestion issues, and a singular value decomposition based approach to optimize congestion using RLNC in wireless networks. Are you ready, sir?
Yes, ma'am. I
Yeah,
am ready, ma'am. I can I proceed?
yeah. You can share your screen, please.
Yes. Ma'am, is it visible?
Yes, sir.
Slides are visible, ma'am.
No, not yet.
Can I proceed, ma'am? Not yet.
No. Please share your screen.
I've gone into slide share.
No, sir. Your screen is not visible. Just click on.
Okay, okay. I'll try. I'll try.
Just click on the share screen and go to
And that
this.
screen share.
Yes.
Is it visible now?
Yes, yes, yes. You can start.
Okay, ma'am. Good afternoon to everyone. Myself, Syed Abid Hussain, a research scholar associated with VTO, Belgavi. My paper topic is a revolutionary transformation network congestion issues and singular value decomposition based approach to optimize congestion, because as such congestion is one of the big headache in all types of network, including wireless area network, say wireless mesh network, etc. So the flow of the talk goes like this: introduction, a small literature survey, followed by methodology, and followed by results and discussion. So, for first and foremost, I am attempting to show some typical types of networks like MANET, WANET, wireless sensor network, and wireless mesh network. So, my problem definition goes around all these types of network, because I know and everybody know that all these sorts of network suffer from the main and common enemy, that is called as congestion. So to go towards 6G, 6G is a big challenge with respect to this congestion problem. So that's why the whole world is having a lot of expectation from the 6G network, which is going to be implemented almost near around 2030. So why it is so important? Because we are going to have a conjunction of all these types of network like smart factory network, smart city network, autonomous driving, and very smart AI enabled cellular network. If you can see in this table, the generation goes like this, and followingly the year of introduction and associated data speeds and network capacity and network latency. If you go particularly toward the last point, that is 6G, we are seeing that the latency suffered will be almost nil or say ultra low. Low means it is a very highly congested, say highly configured network. So that's why we should be able to give our best in the 6G network. So 6G background and highlights. So vision statement of 6G network is ubiquitous wireless intelligence, and it has been postulated in the year March 2019. So the network 6G network will be totally AI enabled. Topology, protocol, and all operations will be AI enabled. So AI will be the main tool while solving all the issues in 6G. So the devices will massively connected and will be having high reliability expectation from this 6G network, because it will be M to M, machine to machine, and human to machine interface. S to M is human to machine, and M to M is machine to machine interface network will be a reality in this 6G network. So coming to the concept that I am trying to solve the congestion problem in 6G network, though it is already discussed and a lot of research papers have been put forth, discussed across the world, that is called as network coding. So network coding, in that one I am taking random linear network coding to define and solve and attempt the problem of congestion. Briefly say, suppose the source node is having some packets to send to the node 1 and 2. So the packets will be XORed and sent to the relay node, say 3, then 3 to 4. So here the packets will be XORed and it will be relayed to the next node so that they can reach their respective destination. So that is the main concept of random linear network coding. So next slide. So this is how the packets will be XORed. This is a one packet, this is another packet, and that will be XORed, and this packet will be relayed to the next node. So this is one more sort of packet encoding technique. So these are the supporting algebraic equation for that, and this is the algebraic equation for the intermediary node, which is going to encode the received packets from the previous node. Next, coming to seeing what are the benefits we may achieve by using this random linear network coding. So we can have a reduced delay, we can have enhanced throughput, we can have enhanced security. So there are different types of network coding that I'm not going to go into that because that is not the theme here. Next, some brief literature survey here. So at present it is not clicking. So better I'll go to the next one. So next, this is where my problem definition. So suppose the user, it is sending the packets. So we are going to perform here the random linear network coding. Then we'll send the packet to the next node. And here, suppose this is a channel where the congestion problem arises in the 6G network, right? So congestion will be solved by applying this SVD. SVD is a known mathematical tool. Its long form is singular value decomposition. Singular value decomposition is a technique which is able to solve a very high rank matrices, because packets will be in the form of matrices only, and this technique has been found to be very useful in solving a very third order, fourth order, or say nth order matrices. So if you are able to minimize the computation in a minimum amount of time, I want to say that I want to propose that the congestion problem can be solved to a larger extent, because the unnecessary data can be reduced, the repeated data can be reduced, and this is how we can able to overcome the problem of congestion. So at the receiver node, the packet will be received and decoded, and we are going to perform the computation of the QS matter parameters like delay, throughput, etc. So I've done some calculations that I'm defining it here. Suppose there is one problem of one link failure, two link failure. I've compared this one with my method, and I've found that at an average, most of the parameters that are being met by my methods are showing better results. So coefficient of variation is one of the mathematical tool that I'm using in this singular value decomposition using linear regression techniques. So it is defined as coefficient of variation is defined as the standard deviation of the value divided by its average value. So that I'm going to take in defining whether the figure of merit, that is SVDL ULR, is better, in which case, that is just a simple RLNC method with one link failure or two link failure, like this. So this is the average value I am getting. So at an average, my method say that is proposed method is showing better, that is 24.17 is the value I am getting. Next I shown some graphs here that are nothing but the result of my
Dear presenter, you have 2 minutes.
Packet loss. Then say next is throughput entropy, say throughput. Then say we have proposed some other things like throughput is there, then packet delivery ratio is there, then finally say jitter is there, right? So concluding remark, this random linear network coding using singular value decomposition is proven to be a very efficient technique to solve the time consuming problem in the network. So future direction for this research is we can apply vendor muter matrix. Vendor muter matrix is one more technique that can solve it as can serve as an alternative to singular value decomposition. So this is my references, and thank you. Any question?
Thank you. Any questions, ma'am?
You said that your method is going to be applied to any of the network, it will work fine, right?
Yeah, ma'am. Yeah.
So what specific QS measures you have taken, like jitter and whatever what exactly the parameters you have taken, quality of service parameters?
Madam, quality of service parameter are taken it as say jitter is one parameter, madam. Because
Hmm.
jitter is nothing but the average delay that can be encountered by any node, whether it is a relay node or any destination node. So delay can be
Okay.
minimized using singular value decomposition using linear regression technique. That is my technique. Because the computation will be minimized, madam, at any intermediate node where the packets will be received.
So, so how does the application of this SVD ULR affect the overall quality of service of a network?
Ma'am, since as this technique is able to minimize the number of computations required while doing encoding of the packets, received packet. So since computation time will be reduced, definitely the parameters will be enhanced.
No, but how you are sensing the congestion first of all.
Ma'am, congestion will be there, no ma'am. You take any network, so time taken by any ordinary method, time or say throughput will be maximized, packet delivery ratio will be
No,
maximized.
that means you're assuming that congestion is there and you're applying your method to that.
Yeah, ma'am. Congestion I'm assuming and I'm solving, trying to solve that.
Okay. So this computational complexities, so scalability, how you're addressing that scalability of the approach, that means the computational requirements, how you're going to how that will help assess the feasibility in case of large networks, Now the different networks will have the different features, right? How your method is going to address in common to all these networks.
Ma'am, irrespective of the type of network, as I discussed in my first slides, wireless mesh network, vehicle area network, the common theme will be, say, packet trafficking. Packets will be sent from different nodes. Packets will be reaching to some intermediary node. At that time, I'll be performing encoding. In the process of encoding, as I showed the encoding process, I'll be minimizing the computations, number of computations. So this is how
Okay,
the number of computations are reduced. Definitely the congestion will be reduced.
okay, okay, fine, fine.
Thank you, ma'am.
Yes.
Thank you.
Thank you, ma'am, for giving me your valuable time and giving an opportunity to speak my work.
Thank you. Thank you, sir.
Thank you.
So we have our next presenter with us, Ajay Singh, who would be presenting a paper on deep learning for uncovering of fraud, a design for automated financial protection. Sir, can you hear me?
Uh, yes, ma'am.
You
I
can share your
can
screen,
hear
sir.
you. Good afternoon, everybody.
So please share your screen.
Yes, yes, ma'am. Yes, ma'am. Yes.
Yes,
Is
sir.
it visible?
Yes, sir. It's visible and you're audible as well. You can start, sir.
Oh, thank you very much, ma'am. This is the paper related to deep learning for uncovering of fraud, a design for automated financial protection. So, deep learning in fraud detection. Uh, there are some basic thing related to this. Deep learning revolutionizes fraud detection by leveraging multi-layered neural networks to analyze vast and diverse datasets to uncover hidden non-linear patterns in financial data, enabling real-time identification of sophisticated fraudulent activities. With hierarchical feature extraction and adaptive learning, deep learning systems autonomously evolve to combat emerging fraud schemes. Despite challenges like data imbalance, model interpretability, and scalability, this technology redefines traditional approaches, offering unparalleled accuracy and efficiency in the safeguard against financial misconduct in increasingly digital economy. So there are some key features of deep learning. Hierarchical attribute extraction. This discover intricate pattern in data. And next is the learns and improves detection systems. Application heterogeneous dataset unveils hidden non-linear pattern in monetary data, operates autonomously in real time, enabling proactive fraud identification. So how it is useful in fraud detection? Deep learning is highly useful in fraud detection as it enhances accuracy, scalability, and adaptability. One is the real-time detection, identifies fraudulent activities instantly, preventing potential losses. Pattern recognition, discover hidden and complex patterns in large unstructured datasets. Scalability, handles massive volumes of transactional data efficiently. Adaptability, learns and evolves to detect emerging fraud schemes. Then automation, reduces manual intervention, saving time and resources. It strengthens financial security by minimizing risk and mitigating losses in digital transactions. Then here advantages and challenges in deep learning. So some advantages are there. First one is the real-time analysis, adaptive responses to emerging fraud scheme, enhanced accuracy, effective handling of complex data sets, operational revolution, redefines traditional fraud detection paradigm. Then there are some key challenges also in the field of that deep learning. Negative resilience, sensitivity to adversarial attacks, data imbalance, skewed distribution, legitimate cases, interpretability, difficulty in understanding complex model decisions, scalability, ensuring efficient processing of massive data sets. Then what a research methodology we adopted for this? The sample size we have taken is 353, and the objective of the study is to conceptualize and validate a deep learning framework with advanced neural architectures and anomaly detection algorithm, addressing scalability, adversarial robustness, data imbalance, and regulatory compliance. Then research design utilizes multivariate regression analysis on pre-processed transactional data, assesses predictive efficacy of variables like algorithm complexity, user trust, cost effectiveness, and adaptability, employs statistical tools, ANOVA, and residual analysis to evaluate reliability, normality, and linearity, validates the framework's capability to enhance fraud detection, accuracy, and financial systems. So what are the results of the study? First one is that high predictivity strength. The model explains 75.2% of the variance in the fraud detection accuracy. That R square is 0.752, indicating strong predictive capability. Significant predictors. Algorithm complexity and model training effectiveness significantly contribute to fraud detection accuracy, as evidenced by their high t-values and low p-values, that is 0.05. Limited impact of other variables. Variables like user trust, cost effectiveness, and adaptability to new fraud patterns showed weaker or negligible effects on accuracy. Model robustness. ANOVA results confirm that the predictors collectively and significantly influence fraud detection accuracy. That p-value was less than 0.001. Then minimal multicollinearity. Predictor correlations are weak to moderate, ensuring the model's stability and reliability. Residual analysis. Residuals are normally distributed and homoscedastic, supporting the model's validity. Presence of outliers. A few outliers were identified but did not substantially affect overall model reliability. Validation of hypothesis. The model meets statistical assumptions of normality, linearity, and homoscedasticity, affirming its soundness for fraud detection tasks. Then the last is implication of the study. Enhances real-time fraud detection capabilities within financial systems, promotes scalability and adaptability to handle evolving fraud patterns,
Dear
strengthens
presenter,
compliance
you have
with
2 minutes
regulatory.
left. 2 minutes
Yes,
left.
this is last one.
Okay.
Okay. Strengthens compliance with regulatory requirements for financial security, optimizes resources allocation by automatic fraud detection processes, builds stakeholder trust through improved system accuracy and reliability. And the last one is the conclusion. Deep learning frameworks significantly improve fraud detection accuracy. Algorithm complexity and training efficacy are critical contributors to model performance. The predictive framework exhibits robustness with minimal multicollinearity. Statistical analysis confirm the model reliability and validity. The study highlights challenges like data imbalance and interpretability. Outliers in residuals indicate areas for model refinement. So these the scalability and adversarial resilience are key strengths of deep learning in fraud detection. The framework redefines automated financial security in the digital economy. It sets a foundation for integrated advanced AI tools in the fraud prevention. Future research should address unsupervised learning for novel fraud patterns. So, so thank you very much for this.
Thank you, sir. Any questions, ma'am?
So, how does the integration of CNN and RNN contribute to detecting fraud in financial transactions? The method which you have implemented actually, how you got the results and what is that method? I have not got it more.
Could you repeat the question, please, ma'am?
How does the integration of CNN and RNN contribute to
Actually, we have taken some keywords like financial security, deep learning, artificial intelligence, robust neural work, machine learning, and fraud detection. So that our dependent variable is the fraud detection accuracy. So in that analysis,
So,
that regression analysis, we have said definitely play an important role in that fraud detection accuracy.
this CNN and RNN. So how you are integrating that to contribute? How this integration of CNN and RNN contribute to detecting fraud in financial transactions specifically?
Yeah, we are trying to find that how AI play a role in the fraud detection accuracy.
Okay, the framework, whatever you have worked on and got the results out of it. So how that ensures a real-time fraud detection? That means, have you measured some typical response time for identifying the transactions?
On the basis of our analysis, which have taken the samples, uh,
Sorry, sir, I could not hear you.
we correlated our dependent variable fraud detection accuracy. Those were independent variable, like adaptability to new fraud patterns and model training
My question
effectiveness,
is,
algorithm complexity.
my question is, what is the typical response time for identifying fraudulent
Sorry,
transactions? My question is, what is the typical response time for identifying this transaction?
response time.
So first of all, does your framework ensure real-time fraud detection?
That response time, it is not mentioned here because we have taken some special keywords like to prove that thing, that how it is playing a role. Our top themes were that financial security, neural network, machine learning, and fraud detection. So that time variable was not.
So can your framework be utilized for other areas also, like healthcare or some different, apart from this financial transactions or financial services? Healthcare or e-commerce, or can this framework, can it be adapted for fraud detection for other sectors also?
Basically, it was related to that in financial, we did because real time expect.
Are you ready with your presentation?
Yeah, ma'am.
Yeah, you are presenting a paper on multi-relational graph attention-based deep depth-wise separable convolutional neural network for spatio-temporal epidemic forecasting. Ma'am, you can start sharing your screen.
Okay. Just a
Yeah.
minute.
Fatima, please fix your connectivity issue and be ready with your presentation. You will be presenting next.
Is it visible?
Yes, it's visible and you're audible as well. You can start.
Okay. Well, thank you. A very good evening, everyone. My name is Hema, and I'm here to present my research paper on multi-relational graph attention-based depth-wise separable convolution neural networks for spatial temporal epidemic forecasting. This research was conducted in collaboration with Dr. Ravikumar Sugala, our mentor, and our teammates Naga Jahnavi and Ananya Sai, and Soumya Prasanna and Harkiti. So we are from Sri Vishnu Engineering College, Pune. So about this project, our problem states like this: existing epidemic forecasting models struggles with noisy data and lack of spatial temporal causality and poor long-term predictions. So we are trying to propose a solution for that problem where the algorithm is like multi-relational graph attention based depth-wise separable neural network, which was combined with an optimization algorithm called Santin-Bauer. So our results are like this, where RMSE is 1231, where MA is 13823. And if it come to the introduction, effective epidemic forecasting is vital for both informed public health interventions and as well as resource management. Despite advancement in model techniques, current approaches often face issues with noisy data and weak spatial temporal correlation and limited accuracy over extended prediction periods. So, in this study, we introduced an innovative model designed to overcome those challenges and improve forecasting precision and reliability. So our proposed model introduced in multi-relational graph and enhanced with satin mobile optimization. Next, the depth-wise separable convolution neural networks to capture spatial related data and Sandin-Bowed optimization algorithm predicts reduced convolution complexities, and this image depicts just a minute, where this image depicts that depth-wise separable convolutional network used in CNNs for effective computation. It breaks down standard convolution network into two steps, where the first step is depth-wise convolution applied a single filter to each input channel independently, creating an intermediate future map with the same depth. Then point-wise convolution network uses the one-into-one filters to combine these futures maps across channels, resulting in the final output with desired depth. This factorization reduces the computational cost and the number of parameters. And so here this architecture tells how the our model has worked, where we consider the input data from the COVID and as well as the normal future. So we fed the data into the our algorithm, whereas multi-relational graph, and we have also used this sandbox optimization. So this architecture will show you the how our algorithm works, and that's it. And so this Sandin-Bobert automation work like inspired by the matter behavior of Sandin-Boberts, and in these steps, like we can see how the algorithm works. Initialization population. Just a minute. Okay. Initialize population of candidate solutions and then calculate attraction probabilities based on fitness and maintain LSTMs to preserve best solutions, and then update solution iteratively, then introduce mutations for diversity. So our objective is to achieve convergence while avoiding local optima. So our results are like this, where the root mean square error is 1318 to 21, as I said before. And we have used this Python with TensorFlow 2.0 on Google Colab for the training. And we have also considered these COVID-19 statistics for our data, which was considered from the US states. And we have considered the 1,351 countries. So these are the results of our algorithm training, where without the graphical attention and all these Santin Bobard without Santin Bobard optimization and something. Later, the analysis shows like this, where the performance with MSc and MAE are shown here, where the lowest MSc is 0.05% and lowest MAE is 0.05%. So our conclusion is that in our summary, our research presents on innovative optimized deep learning approach to epidemic forecasting. So this model can aid in better pandemic preparedness and decision making. So our achievements are like high predictive accuracy with reduced complexity and effective spatial temporal epidemic forecasting. And the limitations are like computational complexity as our algorithm uses the multi-relational graph and the transformability to drivers epidemic conditions. So this is all about it, and these are the references that we have considered. We considered this a new method for spatial temporal transmission, which was given by Vampire, and these are the references of what we have considered. So this is all about work. Thank you for your time and attention. I'm looking forward to the questions.
Thank you, Hema. Thank you. Any questions, ma'am?
So the models which you have specified over here, so can these models be applied to different types of epidemics also, like influenza or malaria, or is it tailored only for COVID-19?
No, ma'am, it can be applicable for that as well, for those diseases as well.
So it is in general you can apply it to any of the epidemics, right?
Yes, ma'am.
Okay, and then the next question is, how does this model handle noisy or incomplete data? Now, this is often a challenge for real world epidemic forecasting, right? So, how do you handle noisy or incomplete data?
Ma'am, for this one, we have considered two algorithms, right, ma'am? One for the spatial data and one for the temporal data. So, with the combination of these two models, we have overcome this, cleaning this noisy data, ma'am.
Incomplete data or noisy? Both can
Ma'am,
be. uh,
yeah, ma'am. Can be dealt with these two algorithms.
okay. Okay, Deepika, I'm done.
Okay, ma'am. Thank you. Thank you, Hema. Thank you.
Thank you as well.
Fatima, are you ready now?
Yes, ma'am. Sorry,
Please
ma'am.
share your screen. No problem. Please share your screen. Yes, your screen is visible.
Assalamu alaikum, ma'am. My name is Fatima Johra, and I'm presenting my presentation in Bangladesh. My topic's name is enhanced communication for the hearing impact and with the deep learning approach on Bangla Sign Language recursion. So our index, abstract. Abstract sign language recognition for faster communication for the deep breaking and bearing CNN model classified Bangla sign language gesture achieved the 98.58% and 94.86% accuracy on data set with the 30 and 36 sign. Introduction. Introduction. A sign language. Sign language is mainly used by the Bengali communication, and sign language is used by more than 7% of people around the global. 22% of the population struggle for contact the sign language. Bangladesh. It's our literature review. Jahid Airtel CNN model accuracy is 91% and Rafi Airtel VGG 19 CNN model is 89.6%, etc. It's our methodology. Our first data set is two-hand data set. So two-hand data set. Our 4,430 RGB image, and 36% different Bangla Sign Language is there. It's our second-hand second data set and one-hand sign language. Our second data set and one-hand sign language images are total 1,530 different image. It's our example and our proposed model. Our proposed model, data accuracy, and pre-processing. We can sharing my pre-processing some picture. Then we apply this data our architecture. We input our input layer is 124 into 124 into 1, and conventional layer is 4. Kernel size is 3 into 3, and padding same. Dropout is 2 layer, and is our output model. Result and discussion. Matrix proposed model is first hand and second hand data set, and it's our final accuracy is there. Final accuracy, and when Jahid Airtel accuracy is 91 point, and our two-hand data set model accuracy is 94.86%, and Suraj Airtel accuracy is 97%, 98%, and 95%. But our model accuracy is 98.58%. It's our curve training and testing accuracy. Then confusion matrix, our confusion matrix for dataset 1 and dataset 2. Some picture and conclusion. This study present this our Bangla Sign Language accuracy is 94.86% and 98.86% for one-hand and two-hand data set. Literature, reference. Thank you. Thank you, ma'am. Any question?
So how was the model's accuracy evaluated? I mean, were there any potential biases or data imbalances that could have affected the performance? Was the data set same, equal for both the cases, one hand and two hand?
Sorry, ma'am, please. Hello.
How was the model's accuracy evaluated? I mean, if you have more representations of one-handed sign over two-handed one, then were there any potential biases or data imbalances that could have affected its performance? Did you get my question?
No, ma'am.
How did you calculate the model accuracy? How model accuracy was evaluated?
Ma'am, actually, when we different model, dataset 1 and dataset 2, then when Jahid Airtel
No,
accuracy.
these two data sets were same?
No, ma'am.
Same number of sample points?
No, ma'am.
So then will it affect the performance. You're comparing the two performances, right?
Yes, ma'am.
So if the base reference is not equal, then will it affect the performance? So that's why I was asking you, how was the model's accuracy evaluated? So if any data imbalance is there, in that case, will it affect the performance or the figures what you are getting?
May I?
Okay, Deepika. you can go
Okay.
ahead.
Yes, ma'am. Yes, sure. Thank you, Fatima. We'll move on to our next presentation. Huzeb Shaifisa, are you here? You are presenting a paper on Open RAN orchestration for 5G and beyond, a comparative analysis of end-to-end deployment capabilities of orchestration solutions. Yes, sir, you can start sharing your screen.
Doing that. Is my screen visible?
Yes.
Hello, my name is Huzeb Shafi, and this is a paper titled Open RAN Orchestration for 5G and Beyond. And this particular study is for finding the comparative analysis of the existing solutions that are available and have been published by other researchers. This is going to be our agenda. We'll talk a little about Open RAN. We'll discuss the actual problem statement that we had beyond this paper. We'll talk about the scope of this particular study that we have in this presentation. We'll talk about solutions and objectives, about the solutions that we compared, we studied, and their comparison, and then finally we'll move on to the closure. This is how the evolution of Open RAN happened. When we go to the back at the start of the telecommunication, we had hardware on the cell site tower. You would go, and the hardware would come from a single company, let's say Nokia, and everything would actually be from Nokia on the tower, the BBU, the RRS, and everything. Then the transition happened to a CRAN, which which introduced a new protocol, CBRI, and then there was an IP traffic kind of opened up, and there was a possibility, slight possibility, that a packet core's hardware can be someone else's. However, it still was kind of centralized and would still continue to be from the same vendor. If Bharti Airtel would take from the components from Nokia, they would end up with Nokia. Similarly, Reliance Jio would take something from Jio, they would end up continuously using their hardware only. So there was a monopoly of these vendors. Then came a virtualization phase where things started to become containerized. And this is where substantial growth happened, and we had virtualized systems. So now the hardware started to become disaggregated. So we had this hardware from, let's say, Dell, and onto it, the software would be from Nokia. Even then, the RRS, and because there was a CPRI protocol for communication with the actual tower and the radio unit, the certain hardware towards the cell towers would still continue to be vendor specific. Then we finally came with the Open RAN, and this is where the 5G comes into the picture. And 5G helped with this 5G actually came up with this Open RAN model, where you have pretty much everything as virtualized as cloud network functions, virtual network functions. It introduces the concept of CU, VDU, and if you see here on this, there are different cell site types possible because of the Open RAN. You can have just the RUs, radio units on the cell tower. You can have RUs and the DUs. You can have RUs, DUs, and CUs, all of this whole of the radio function stack onto that tower. And that would kind of bring in different compute requirements onto the edge. This is just to give a basic idea of how this introduces the front haul, mid haul, and back haul as to depending upon the what a cell site tower contains. If it contains a radio unit, distributed unit, and a control unit, then it will directly only have the back haul connecting to the core network. Now, because of that, this is what it requires. In order to connect to a core network, the cell tower let's say having a bare metal server, which will host the VDU or a CU, which will also need a router. And then this router will connect to the upstream routers, which will further connect to the core network. The thing is that every time you have to bring up a cell tower fully functional, you have to make sure that you bring up the transport link here, the PE routers that we say call out, the upstream routers. These upstream routers need to be configured. The cell site router needs to be configured, provisioned. The bare metal server needs to be provisioned and configured, and software needs to be installed there. And then the cell side is the radio functions, the radio units, they need to be configured as well. This is what it takes. This coming to the problem statement, with that in perspective, coming to the problem statement, 5G, as you know, has changed lots of things. It brings in new speed and flexibility. And because of Open RAN, it enables a multi-vendor diversity. You can have hardware from one person, you can have another software from another company, and so on. And naturally, because of that, if you try to go and deploy it manually, it's error prone as well as time intensive. It can take weeks to bring up one cell site. And that is why it actually makes it possible that we needed to what we wanted to do is we wanted to study the industry standard automation and orchestration solutions. What do we have available in the market? Our total research was, it started with studying the impact of 5G and beyond, that is 5G, 5G plus, such as 6G, and what Open RAN is about to bring in future. Second was Open RAN and automation opportunities in 5G and beyond, understanding what are our automation opportunities. That is where we found the automation opportunity of automated cell site deployment. So naturally, that brought us to the analysis and comparison of existing orchestration systems and solutions. And then we finally ended up developing our own automation cell site deployment of Open RAN. And the analysis and comparison is what we have in this current study, where we took ahead some of the solutions available in the publications that we saw, studied them, tried to compare them. And naturally, because of the nature of this whole research, it became a qualitative research. A quantitative research and comparison was not possible. And we kind of selected only those papers which had an emphasis on the completeness. As I showed in the earlier diagram, that we had different components. We kind of need to make sure that a cell site starts radiating, starts functioning. And so our emphasis because of that was on completeness in order to select the system. And naturally, because of that, those systems it should be possible that we can use them in the real world system. They should not be just a theoretical perspective. And that's where we ended up. After we applied all these selection criteria, we ended up with only 4 comprehensive systems that we selected for the further discussion. And our objectives were to compare them on their multi-vendor support. Do they support multiple vendors? And it's okay not to support all the vendors, but it should be possible to support incoming new vendors who have Open RAN competence. Do we have a practical deployment relevance? Can we actually take it to the real world? Does it cover all the use cases, such as setting up the transport, provisioning a cell site router, bare metal server orchestration and deployment, and then there are RAN function deployment, RUDU, CU chaining, and such things? Does it document the error analysis, and does it show enough fault tolerance so that we can take it ahead for a production scenario, a real world scenario? And then naturally, do they document any of the KPIs? These were our analysis, that the things that we tried to study. So the 4 selected systems, just a minor overview. One of the systems was this, which used ONAP and leveraged and deployed Open Air Interface, OAI, over it. So this is one of the systems. It used Kubernetes integration as a hybrid approach, because in the version that they used of ONAP is an open source system. So they had used Casablanca version, which did not have Kubernetes integration. But yeah, that was after this study a few years later. In a Frankfurt version, Kubernetes support came into ONAP. In all cases, this is what they were doing. However, their limitations, we will discuss those. Second system is the one leveraging directly a Kubernetes-based system for deployment. Every function is taken up as a Kubernetes deployment and deployed and taken care of and they kind of primarily focused on the RAN functions only. Coming to the one of the best ones, they started with a bare metal server. However, they leveraged only the Chef and Ansible and actually such bare systems to actually go and provision the bare metal server and then deploy the OAI, open air interface onto that. The fourth system primarily focused towards 6G, where it kind of centralized everything and had lots of stuff out of the catalogs and services, primarily focused towards the server side and the things it
Dear
would go and take.
presenter, you have 2 minutes left.
Fine. I'll move fast, and it would actually go ahead and provision those ones. Our comparative analysis conducted at our own app, OAI-based system. It was slightly older, but really had good deployment potential. The ones around Kubernetes, that was good for RAN functions, but it did not really document any of the multi-vendor scenarios or other integration possibilities. The MOBMS, the bare metal server system, they did really focus on a lot from the bare metal server and onwards. But did not really cover anything on the transport system. And then our 6G, primarily RAN focused on the 6G and the automation focused. Multi-vendor support, wherever an open source system was used, there was a potential for multi-vendor support, but no explicit evidence was given to mention that. Use cases were not all supported except for MOBMS, which did at least start from bare metal provisioning. The others primarily focused on RAN. 6G primarily focused on RAN itself. None of them actually tapped into the transport and actual cell-side router configuration. There were minimal details about error analysis, KPIs. Everyone primarily focused on the deployment time, which is really a good focus, but most of the other KPIs were kind of missing, which would kind of be the success rate, the error time, the error recovery rate, and such things were still missing, or even the resource utilization. With that, our strengths across these systems, we found that they had substantial strengths. They actually did address the critical deployment challenges that you can see in the real world. They did align with the Open RAN's goals and the flexibility. Multi-vendor support was negotiable. Some of the systems had the possibility, but did not already have it. And it's kind of explicitly not available. Hardly any of those focus on the actual error handling and fault tolerance and standardized KPIs. And that kind of opened up our opportunities for evolving further open RAN technologies and kind of working up further on the zero touch networks possibility. With that, I want to conclude that this is where we had the potential to show the kind of potential that Open RAN orchestration has a potential for 5G, 6G, and beyond. And but yeah, interoperability, use case coverage, error handling will be one of the things that we will have to address. That's pretty much it. This is what the outcome of this particular study was. Thank you. Any questions?
You just mentioned about interoperability. Okay, so what are the most significant limitations in supporting multi-vendor interoperability?
Most of the vendors would have traditionally would have their own interfaces and protocol implementations. And when it comes to Open RAN, they all have to support and come up with the common set of integrations, both from the hardware perspective of interfaces as well as from the software perspective of packet handling and IP traffic handling. And when it comes to integration, for example, if I want to simply interact and leverage, replace a Dell system with Samsung's radio function, any radio function, the problem is that I would need to make sure that all the packets are being exactly being encapsulated them in the manner that they are encapsulated by Dell's let's say system. And that kind of that interoperability at that level is one of the challenging things, because companies traditionally have always used their own system and they would say, hey, this is the efficient way to do it. Other companies are not doing it. We are doing it the better way. And with this is one of the issues, that whenever you want to just add another system to this whole stack, that interoperability, those things can actually creep in at any point of time. So addressing these would require validation and association and testing of all of these integrations one at a time, developing that integration. And if a mapping logic is required for that integration, which often is the case. That mapping logic needs to be kind of supported as well. That is only how these, I mean, these systems can be interoperable or can be integrated into any of these orchestration solutions.
Okay. So have you focused on some specific use case?
Yes, in our whole research, not part of the study, but the extended study of this one, we primarily did focus on the end-to-end cell-side orchestration. So the idea is a service provider will go.
So no, so how do these different orchestration systems perform across these scenarios, different scenarios?
Yes, it is kind of difficult to compare because most of the studies that we had, they deployed OpenAI interface to actually give the feel of OpenAI interface is is an open source RAN function providing the RU, DU, and CU, and it is just open source, not leveraged by the commercial players. While many commercial players support it financially and its development, but most of the commercial players go for the big shots like Mavenir, Samsung for these radio functions. So naturally, because of that, all of these systems are like proof of concepts. Yeah, this can work, but none of them showed the capability of having done it on the real world system. And that's what we changed. We ended up actually evaluating our system and developing our system against a real world system, especially from Avenir for the RAN function deployment.
Okay, okay. Over to you, Deepika.
Yeah, thank you.
Thank you. Thank you very much. We have our next presenter with us, Mukund, who would be presenting a paper on revolutionizing healthcare, contributions and considerations of AI in clinical practices. Yes, sir, you can start sharing your screen, Mukund.
Good afternoon.
Yes.
I am Mukund Kuthe, a second year computer science student at Symbiosis Institute of Technology. The paper explores AI role in revolutionizing healthcare, its advancements, challenges, and ethical consideration. This is the flow of content. AI is transforming healthcare through advancement in diagnostic, treatment, and patient management. However, challenges like data security bias and ethical concerns must be addressed for responsible implementation. AI enhances diagnosis, precision medicine, and healthcare efficiency. Its rapid adoption, accelerated by the COVID-19 pandemic, highlights both its potential and ethical challenges such as data privacy and accountability. The literature survey helps address healthcare disparities, particularly in rural areas. Robotics, automation improve efficiency, but challenges like cost, training, and ethical concerns require careful management. AI technologies, including deep learning and robotics, improve medical imaging, real time monitoring, and personalized treatments. However, concerns about data security, bias, and regulations must be resolved. AI enhances diagnostics, predicts health risk, and personalizes treatments. Uh, Wearables tracks vital signs, enabling early detection and better patient care. AI and robotics in healthcare raise ethical concerns like data privacy, security, and fairness. Sensitive patient data must be safeguarded with encryption and access controls, while AI systems need to be transparent and free from biases. Strong governance frameworks ensure fairness, accountability, and regulatory compliance. International guidelines help standardize AI applications for ethical and safe use. AI's future in healthcare includes robotic surgeries, predictive analysis, and AI-driven drug discovery. Addressing ethical security and regulatory challenges will ensure its sustainable integration. These are the references that are used in the research paper. Thank you.
Thank you, Mukund. Any questions, ma'am?
So what was your work about? Was it only going through literature survey?
Ma'am, literature survey only. Review on AI in healthcare.
So only taking the review AI in healthcare. What is the role of AI in healthcare? So can you give some specific example of AI-driven devices or technologies which has been successfully deployed in clinical settings?
Ma'am, AI monitoring systems are used in many medical colleges,
Specific
which helps to
example,
monitor the patient health.
no, specific example of AI-driven devices, AI-driven devices or technologies which has been successfully deployed in any clinical settings. You can give one example which is already existing. Apart from the literature survey, have you surveyed and seen the current state of art which is being implemented already around you in the society or in any hospitals?
No, ma'am.
Okay, Deepika, you can go ahead.
Yes, ma'am. Thank you. Thank you, ma'am. Thank you, Mukund. Do we have the presenter of the paper Smart Healthcare Systems and Artificial Intelligence, Leveraging Data-Driven Solutions in Healthcare? Sidra, or any co-author of this here paper, please? We just wait for 5 minutes. I request all the participants to be with us till 5 minutes, please. We wait for the other author. Otherwise, we can just close the session. Just for 5 minutes, please. Thank you. All right. We have come to the end of this session. I sincerely thank our authors for their excellent contribution and presentation in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. I, on behalf of the whole team, thank you for your support during the 9th version of this conference and all the previous 8 versions as well. We will be happy to see you in the 10th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have been forwarded to the Springer board and the publication will be live within 6 months. Kindly cooperate with the team of the SmartCom. I also thank our session chair. Thank you for chairing the session, ma'am. It was great to have you here. This is a token of appreciation from our side, ma'am. Thank you so much.
Thank you, Deepika.
Thank you, ma'am. Thank you for your presence. It was great to have you.
Thank you.
Thank you. Yes.
Um, is
Share
my
your
presentation
presentation and start soon, please.
okay? Is my presentation can you
I can just see your screen, but yeah, you're fine. The presentation is visible now.
okay, ma'am? Can I present it now?
Yes, faster, please.
Um, okay. Good morning, everyone. This is Sidra Zedi. I am a student of Christ deemed to be university. I'm going to present my paper on artificial intelligence on healthcare and how it affects cybersecurity and its impact on AI's impact on it. So, abstract AI improves healthcare AI improves healthcare efficiency and diagnosis. So, as we okay, as AI, as we the artificial intelligence healthcare by improving efficiency and streamlining disease diagnosis. So, by using AI in real time, so we have Internet of Medical Things and wearable devices. So AI enables personalized treatment
that cater to individual patient need. So we have AI in healthcare. Even though there are a lot of that AI can help a lot and help us increase the efficiency and diagnosis through using it with a lot of wearable devices that can help us to detect diseases early. There are a lot of challenges that come, such as there are large number when a healthcare is using data. There is a huge amount of data that they have that they need to protect about the patient. So it is a very sensitive place where hackers have more and more chances of adopting it. So AI can be used to reduce human error and also used to protect these data by using them in cybersecurity. Now, despite these challenges, the ultimate goal is to create a patient-centered healthcare system where technology complements human expertise. The few keywords that are being used majorly are artificial intelligence, cybersecurity, Internet of Medical Things, healthcare, and disease diagnosis. Introduction. Artificial intelligence is transforming healthcare by improving disease diagnosis, administrative process, and operation efficiency. It fundamentally reshapes healthcare, making it more efficient and responsive. One of the most significant contributions of AI in disease diagnosis is where machine learning algorithm can analyze medical records, imaging scans, and pathology reports to detect diseases at early stage. For instance, there is IBM Watson Healthcare, which is well-known AI platform that processes vast amount of medical data and provide doctors with insights. Now, a real-time data analysis is enabled through technologies like the Internet of Medical Things, wearable devices, and medical imaging. So, IOMT is Internet of Medical Things, where medical images, it enables early interventions and make accurate treatment planning. Few of examples of Internet of Medical Things would be smart watches, which help detect the data and which when we are going for jogs or morning walks, and it can detect our heart rate or breathing oxygen level in our body. It helps us to know about our medical conditions, as well as it helps the doctors also to alert them. Now, literature review. Evolution of smart healthcare system. Healthcare integrates AI, blockchain, and Internet of Medical Things to improve patient monitoring and healthcare delivery. So integration of AI into smart healthcare system is deeply connected with the emerging technologies. Now, these technologies are crucial in improving patient monitoring, ensuring data security. Wearable devices like Fitbit and Apple Watches have become essential tool in personal healthcare managing, tracking vital health parameters, and alerting users to irregularities in real time. Internet of Medical Things plays a vital role in remote patient monitoring and early diagnosis. So it reduces the need to frequently visit the hospital. For example, a remote glucose monitoring device allows diabetic patients to continuously track their blood sugar level and share data with healthcare providers instantly. Cyber challenges and in smart healthcare. Increasing reliance on digital healthcare system makes them vulnerable to cyber threats like ransomware and data breach. Healthcare industry is increasingly becoming digital, which while bringing innovations also expose medical systems to cyber threats. A well-known example is WannaCry ransomware attack, which targeted the UK's National Healthcare Service, shutting down computer systems and having patient care. This attack highlighted the vulnerability of outdated healthcare infrastructure and lacked strong cyber defenses. So challenges include outdated infrastructure and data privacy concerns. Solutions such as lightweight encryption and chaos theory based protections are being explored to such medical data. AI driven solution for healthcare cybersecurity. The integration of AI into healthcare has opened a new area for efficiency, but has also increased significant cybersecurity challenges. Medical data are highly sensitive, and cyber criminals are increasingly targeting healthcare institutions to steal patient records. Self-learning AI can adapt to evolve cyber threats more effectively than in traditional security methods. So, outdated hospital network makes it easy for cyber criminals to access confidential medical records. The reliance on interconnected systems mean that a single breach can compromise an entire healthcare network. There is an example is Dark Trace. It was an AI-powered cybersecurity system that detects and responds to cyber threats autonomously in healthcare network. Key themes that are being discussed in the paper are roles of smart healthcare in Industry 5.0 in patient care, enhancing cybersecurity in healthcare, and leveraging AI in cybersecurity. Now we'll discuss few role of smart healthcare in Industry 5.0 in patient care. So artificial intelligence has emerged as a powerful tool in strengthening cybersecurity in healthcare. AI-driven intrusion detection system analyze hospital network traffic and flag suspicious activity, preventing data breach before they occur. Now, the components of smart healthcare include implantable and wearable medical devices. Used for continuous patient monitoring, for example, smart healthcare pacemakers that track heart rhythms and send data to doctors. Then there are wireless communication which enables remote data transfers to healthcare providers. For example, telemedicine platforms like Teladoc Health enables virtual consultation. And then there is data analytics, which helps analyze physiological data for predictive healthcare. For example, AI-based platforms like Google DeepMind assist in detecting eye diseases from retinal scan. Then there is improved cybersecurity framework. Cybersecurity threat includes data breaching, ransomware attacks, and unauthorized access to making devices. Now, as AI healthcare becomes more dependent on digital technologies, it also becomes more vulnerable to cybersecurity threats. These threats include data breaching, ransomware attacks, and unauthorized access to medical devices. Since hospitals stores vast amount of patient information, including medical histories, financial records, and treatment plans, hackers often target healthcare system to steal and manipulate sensitive data. One of the most alarming case of the healthcare data breach was the 2015 Anthem cyber attack, where hackers compromised 80 million patient records.
Yes,
This
ma'am.
breach
Can you please conclude?
um, sure, ma'am. I'll go to the conclusion. So, artificial intelligence has become a transformative force in healthcare, improving disease diagnosis, treatment planning, patient monitoring, and cybersecurity. Its ability to analyze vast amount of medical data quickly and accurately is revolutionizing healthcare delivery. However, these advancements also come with significant ethical and legal challenges. The biggest concern revolves around data privacy, bias in AI decision making, and compliance with General Data Protection Regulation and Health Insurance Portability and Accountability Act. Um, by addressing these challenges thoughtfully, a future of AI in healthcare promises to be not just more advanced, but also more secure, fair, and patient-centric. AI has the potential to make healthcare more accessible and personalized for all. But its success will depend on how responsibility we develop and integrate these technologies into medical practices. These are, then I have few references that are being used. Thank you, ma'am. If there is any question.
Thank you. Thank you, Sudhira.
So
Yes, ma'am. Any questions, ma'am?
what are the key performance metrics used to evaluate effectiveness of AI in healthcare?
Sorry, ma'am. Can you please repeat?
What are the key performance metrics used to evaluate the effectiveness of AI in healthcare?
Ma'am, the things used majorly to evaluate the implementation of AI in healthcare, they were so the concept of Industry
No, no,
5.0.
no, 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 no. I don't want that. Just key performance metrics, which will define the effectiveness of AI in healthcare. Performance metrics.
Ma'am, there are various devices that are being used,
No,
and
no, not devices, performance metrics. Okay, fine. What steps you will need to take to ensure the scalability of AI-powered healthcare systems? Suppose the globally the demand increases. So what steps need to be taken to ensure the scalability of AI-powered healthcare systems?
okay, ma'am, as AI is taking over healthcare more and more, I think majorly the things that we can use, the steps that can be used to prevent any sort of malfunctioning or any, is to keep a proper check or a proper system or a proper committee that is being used just
No,
for
no,
the
here,
protection of the data.
no, no, here you need to mention the scalability challenges. What are the scalability challenges? Can you speak on that?
Ma'am, there are various scalability challenges that I think that are used. Since AI, it can be biased because of who are going to be making the data, who are going to make or create the AI. They have their own biases. So if the AI is using that as its pattern or one of its, so there are a lot of challenges that will occur in that sense. But if there is a proper survey that is being made to prevent or to
Okay.
constantly check the AI, then it is going to.
Okay, Sidra. Okay. Yes, Deepika, you can go ahead.
Yes, ma'am. Thank you. Thank you, Sidra. Thank you.
Thank you so much.
So we have come to the end of the conference. Thank you, everyone. I request you to turn on your cameras for a quick snapshot, please. Sidra, just stop sharing your screen. Yeah. Thank you, everyone. Thank you. Thank you so much. Stay safe. Take care. Thank you.
Thank you.
Thank you, ma'am.
Thank you, everyone.